Hey guys, this video is my submission for the MAT 104 End-Sem evaluation. The question is in the description below. We have a room which has 20,000 cubic feet of air. Let's call it mixed air for the sake of convenience. Given that fresh air enters the room at a rate of 600 CFM, which is cubic feet per minute, and exhaust rate is also 600 cubic feet per minute. What happens here is fresh air is entering the room. Now, parts of the mixed air is also fresh air. The mixture leaves the room at a rate of 600 cubic feet per minute. Let's say Y equals the amount of fresh air in the room at any given point of time t. So if you observe, initially we have mixed air and the number of parts of fresh air in it is 0 initially when time equals 0. Y dash is the rate at which amount of fresh air in the room changes. So we have Y dash equals inflow rate of fresh air minus outflow rate of fresh air. So what's happening here is fresh air enters the room at 600 cubic feet per minute and fresh air leaves the room at a certain rate. So the difference between these two rates gives the rate of change of fresh air within the room. The inflow rate would be 600 cubic feet per minute because we have pure fresh air coming in, and the exhaust rate is 600 CFM, but that has mixed air. So how many parts of it would be fresh air? We have Y parts in 20,000 cubic feet if we consider a time instant t. So at that time instant, we're going to have Y into 600 by 20,000. So that would be our outflow rate. The difference between them gives us the rate of change of fresh air within the room. Y dash equals 600 minus 0.03y, which gives dy by dx equals 600 minus 0.03y, implies 1 by 600 minus 0.03y dy equals dt. Taking integration on both sides, we have 1 by 600 minus 0.03y dy equals integral dt. Multiplying and dividing by minus 0.03, this is f of t and this is f dash of t. Integral f dash of t by f of t is ln of mod of f of t, which gives us ln of 600 minus 0.03y minus 1 by 0.03 equals t plus c. Let's take the initial conditions over here. At t equals 0, we have 0 amount of fresh air in the room because fresh air hasn't started filling in the room. Let's substitute those conditions. We get minus 1 by 0.03 natural logarithm of 600 minus 0 equals c. Implies c equals minus 1 by 0.03 natural logarithm of 600. Substituting it over here. So we have minus 1 by 0.03 natural logarithm of 600 minus 0.03y equals t minus 1 by 0.03 natural logarithm of 600. Just multiplying it by minus 0.03, we get natural logarithm of 600 minus 0.03y equals minus 0.03t plus natural logarithm of 600. Taking exponentiation on both sides, we get 600 minus 0.03y equals 600 times e power minus 0.03t. 0.03y equals 600 minus 600 times e power minus 0.03t 1 minus e power minus 0.03t equals y, taking this to the denominator, y equals 20,000 times 1 minus e power minus 0.03t. This equation describes the amount of fresh air in the room at any given point of time t. The question asks us to find after what time will there be 90% of fresh air in the room. So 90% of 20,000 cubic feet would be 90 by 100 into 20,000, which is 18,000 cubic feet. For y equals 18,000, we are required to find t. Let's substitute that in this equation. We get 18,000 equals 20,000 times 1 minus e power minus 0.03t. 9s, 10s, 0.9 equals 1 minus e power minus 0.03t. E power minus 0.03t equals 0.1. Taking natural logarithm on both sides, we get minus 0.03t equals, which equals minus 2.302, implies t equals minus 2.302 by minus 0.03, which gives us 76.75 minutes. Our answer is in minutes because our rate is cubic feet per minute. Hope this video was understandable. Thank you. Have a great day.